I don't see any more participants yet, but now there are a few. Hello to everybody coming online. Welcome. So we are going to start in just a while. Let's have people come in. So just a minute more. Okay, I will start talking a little already because everyone who joined can already start doing something. If you look at the program I have now shared to you, the whole point is that we will very shortly try to give a quick view into the 5 different pilots that we have. Then the idea is that we still would also have a lot of time after these presentations to discuss around those questions that I have put up. And especially for everyone who is kind of not in the teams presenting, I would hope that you could, there is this make questions part on the meeting virtual site, that you would, as I already put there, one question, that everyone could just present themselves, put their names, tell where they are coming from, and then they could go through and answer. You don't have to answer all the questions, but the questions that you feel that you can answer to, you would write those as another question in a way. We don't have a kind of chat box there. So it is like you would pose a question where you in fact actually write those answers to those questions, because we will try to then have the discussion based on these questions afterwards. So I hope that during the presentations that we will do, the people who are not presenting feel the time to also type in some answers to these questions, and that would really help our end of the session to be interesting and full of some material that helps us do our job. But that's all I wanted to say in this part. So let's go then into the program, and I don't see if Ville is online. So I am a little hesitant in the sense that Ville was supposed to, of course, present. I only see Jake, who is in the pilot 1 online, and I guess Jake is not prepared to make a talk. Can Jake comment something? You can unmute yourself and say something. Okay. Well, I guess if Ville is not here, we will just have to jump forward, and I would ask then Saskia to, I stop sharing, and Saskia can start sharing, and we start with pilot 2, and then when Ville comes online, we will get him. Yeah, okay, Jake, thanks for the answer. I got it. But now let's have Saskia Buchholz from DWD start and present. Thank you. Go ahead.
Okay. Did you unshare? One moment, please.
Yeah, sorry, it did not react immediately. Now it should be okay.
Do you see the presentation?
It came up now. Yes, we see it.
Okay,
go ahead.
Perfect. Yeah, then I want to introduce myself shortly. My name is Saskia Buchholz, and I'm working at the German Meteorological Service. And together with my colleagues, Andrea Vajda and Chris Schubert, I want to give you the overview on our pilot on urban resilience to extreme weather. So our pilot is threefold and has the goal to strengthen urban resilience and preparedness to extreme weather. We're developing 3 different pilots that use time scales from sub-seasons to centuries. And in the development of the pilot, you see the 3 institutions that are involved. So the first of it is the Finnish Meteorological Institute, then the German Meteorological Service, and last but not least, the Zentralanstalt für Meteorologie and Geodynamik. And I give you now a short overview on the DWD pilot that focuses on summer hot and dry conditions. So our goal is to create seasonal forecast products that are mainly tailored for city authorities. And we're focusing on the summer months, on the heat and very long dry periods. And we want to help the city authorities to plan and prepare better for long-lasting and severe heat waves and for urban green irrigation. This was really a problem within the last 2 years in Germany, where we had really long, very dry periods, and in some regions we had really problems with the water resources and also the distribution of water among different sectors. So our pilot should include graphs of time series and also tables up to 6 months ahead. And we want to present the graphs as an ensemble mean prediction and also as a probabilistic prediction. And since we also use the global climate forecasts, we want to reach a higher spatial resolution for our city products. So we will use a statistical downscaling approach on the German climate forecast system that is used or that is called episodes. All our seasonal forecast products for the German cities will be freely available, so at no cost, and we will publish our products at our climate prediction website, which is available in German and also in English. So for the timeline, I can say that we plan to have the seasonal forecasts on the climate prediction website by summer next year. They are right now somewhere else located. And we want to be pre-operational with the statistical downscaling approach and the first products for our partner city Aschaffenburg by summer next year. And we try to get operational until the end of 2021. Here you just get an example of how the graphs of the time series can look like. You see in the upper left a graph of an ensemble mean prediction for the next couple of months, and on the upper right, on the lower right side, you see the probabilistic graph. We also give always a prediction skill in the form of these traffic lights showing you if the forecast is usable or not. And within the co-design progress, we want to discuss how the graphs looks like and what the content is with our 12 partner cities. And now I hand over to Andrea, who gives you the information of the FMI pilot for winter maintenance activities in Helsinki.
Thank you, Saskia. I hope you can hear me. So our pilot for winter maintenance activities, actually what motivated this pilot is that the cities are responsible for the maintenance of the streets, which might be quite challenging during winter. They have to plug the snow, they have to remove the snow from the cities, and of course they have to take care of the slippery conditions and also the cleaning of the streets during spring. So our goal is to develop a user-oriented sub-seasonal and seasonal forecast products tailored for winter maintenance activity. And we hope that by this, we help the city authorities to plan their activities, to better plan the activities and to improve the winter safety in the cities. And our user is the city of Helsinki. We focus in this stage mainly on the capital, and they were engaged from the very beginning of in the development activity of this in the creation of this service. We have selected the climate outlooks together with them, the forecast products. We have designed it together with them, and they are going to pilot it, to test it, and give their feedbacks about the service. Since we haven't discussed or haven't mentioned yet the sub-seasonal scale, we said that we develop sub-seasonal and seasonal outlooks, but what actually the sub-seasonal scale is, it's the next, or it's the 6 week ahead forecast. So basically we will provide description of weather condition in weekly average. And of course, we will provide also seasonal forecast for 3 months ahead. And then the selected outlooks, the selected products are listed here. Actually, it seems that the cities are much more interested in the sub-seasonal scale. So we develop 4 products on sub-seasonal scale: the snow accumulation, the long periods of freezing and mild weather condition during winter, slippery conditions for pedestrians, and condition for spring street cleaning. And we develop also the snow accumulation outlook on seasonal scale. The user opted for a very simple representation mode of the product. So we will prepare a graph of 6 week or monthly outlooks, which describe the likelihood of the weather, expected weather condition through probability forecast. Of course, when developing these forecast products, we have to keep in mind that the skill of the forecast it's somehow limited and depends a lot on the weather, on the location, on the season, also on the variables. So we had to assess the quality of the forecast variables and also to improve the skill of the forecast. And we do this by bias correcting the parameters, the variables used in the computation of the products, like snow, temperature, and precipitation. And of course, then we run the sub-seasonal outlooks on the FMR server, and they will be available through our Ilmanet platform. This will be a fully automated service, and the seasonal outlooks will be produced on Wikio, Dias, and then they will be published on FMI platform. And next slide, please. And I will show you a few examples. The service is not running yet. Basically, the development is done, and we plan to publish the first products in November. And you can see here some examples of products, like the 6 week snow depth outlook, and also the seasonal snow depth outlook. The 6 week snow depth outlook, actually it was initialized last week. It shows not only the expected snow amount for the coming weeks, well, which is right now it's very low, but also it provides also information on the past years, and the climatology. So it makes easier for the user to remember what kind of actions they have last year's and how will those change this year in the same conditions. And then the probability of monthly snow depth for each month. Well, actually this is an example from February, since this year we haven't run it yet. Here we have monthly situations. So that also helps the user to plan well in advance and to prepare. As I mentioned, we would like to test, this will be available in November. We would like to test the service during this winter, then collecting the feedback of the user and to improve the service based on their feedback, after which we can test it again in the second pilot during next winter. So this is from my part, and I would like to give the floor to Chris.
Yeah, hello. Yeah, our goal our part on this showcase is that we have to, or we calculating climate projection products based on for different Austrian cities here, especially for the heat load and heat days for urban planning and risk management processes. So we deliver high resolution maps or information with this climate projection scenarios, as you can see in this picture here. And these data are produced in a close cooperation with WD, because we are using this Muklimo model and also the Guamo method. And at the moment we are testing these approach to scaling up for other cities, because not only Austrian cities, we want to have also go into this level for upscaling in the technical sense to calculate it also for other European cities. Because we want to provide a more consistent representation of these special pattern and dependencies on land use classification and land use methods, what we will be used here. The next slide, Saskia. Yeah. And here I put some examples what we how our distribution channels looks like. One example, this example above here, the European Commission, or especially JRC, is used or using our scenarios. This is an example of the city of Klagenfurt, the south of Austria, where we produced these scenarios of heat days and summer days, and combined with distributed population distribution, also scenarios up to 250, I guess. Yeah. We have here one example of a kind of risk assessment produced by JRC, the Commission, and the Disaster Risk Management Knowledge Center here. And the other distribution channel is where we provide these kind of modeled data as a web-based services. Here, one example is here the city of Vienna, where we calculated and also make the data available of the hot days at an server. It's called data service, or the CCA data center, the Climate Change Center Austria. It's an research data infrastructure component here in Austria. So for me, it was, yeah, I'm finished here with this 2 slides.
Okay, thank you very much. I guess that was then pilot number 2, and I have bad news for pilot number 1. Our Ville is such a wonderfully organized person that he has put it tomorrow in his calendar, and at the moment he's in another meeting for Icos, so it is really hard for him to now jump over and do something. So, but this just means we have a little bit more time for the other presentations, and I let Miriam just then get on with pilot number 3. Please go ahead.
Okay. So can you see my screen now?
If you put it in presentation mode, it's even better.
Yeah.
Perfect.
Now? Okay, so I'm Miriam Kosmale. I'm the pilot lead for the forestry operation support, pilot number 3. And the work of our web application is not possible without collaboration of our colleagues from FMI and our co-design company Metsäteho with Asko Poikela. Forest industry is one of the largest industries in Finland, to say the second largest industry, with about 22 billion euros. So this is the background information why such an web application might have a benefit, also a monetary benefit for Finnish forestry companies. So what is this web application about? It's running on, you can find it on our website, harvesterseasons.com. The web application is launched in May, so it's available. You can go there and test it out. The reason why we built this web application and are offering that is that for very moist soil, the bearing capacity of the soil is sometimes not enough for these quite heavy machines operating in the forest and harvesting the trees. At the moment, the forest operators in Finland are using for operation planning a static map of a terrain characteristic and weather forecast. And this web application is now a combination of this static terrain characteristics together with the seasonal forecast and hydrological model for deriving the soil conditions and providing the users then an easy accessible tool to get information about trafficability within the forests in Finland. So this service is, as I said, combining different layers in this web application. Everything is done on the fly, so all the layers are in the background running in the service, and by accessing the service for each location on the map in Finland, automatically the trafficability will be calculated depending on the seasonal forecast data and the results from the hydrological model. You can see that the static soil classification by Metsäkeskus, which we are using on the right side, had still gaps, and it was only a static information. And we are now improving with our service this information. The complete service is implemented on the Vekeo server, Vekeo DIAS platform within a Docker environment, and all code is pushed to GitHub. So portability and traceability of our service is, as much as we can is provided. What is the trafficability is calculated based on the results of the seasonal forecast ensemble outputs, and depending on the statistic of the seasonal 51 seasonal forecast results, then a trafficability and simple index is calculated. And this is then what the service is providing. You can see a map where the trafficability in an easy index good or bad is then shown in the web application for each location, and the forecast is also available in the service. Additionally, we have also layers of service, such as a tree cover density map, and which was also a user request, forest fire index. In my forest fire risk for yesterday, at the moment it's raining quite a lot in Finland, so nothing to see there, but in summer it was very helpful. You could see then the fire risk, and this is a big issue in Finland. So we have several times per year fire risk, and then harvesting should not be done in the forests. What we are currently doing, what we are doing is continuously a usage analysis via Google Statistics. And for example, in the last few months, most of our users, of course, were from Finland, but also other countries in Europe were testing our web application. And within Finland, we had several users, of course, from the Helsinki area, where our developers and co-designers are sitting, but also from, for example, the Tampere area, which is an area in Middle Finland where more forests are occurring. Usage analysis is also showing that we are distinguishing our users of the web application into users which are only visiting our website only once, or are they returning users. And the number of returning users which are coming back is gradually increasing within the months. So in May, our app was launched. In July and in August, even that we had summer holiday season then in Finland, we did some marketing action, and it directly was reflected in the number of returning users. And now in September, what we have is currently ongoing is a summer user survey. This is done by our co-designer Metsäteho. They have set up now my words are missing. Now my words are missing.
A web form, I guess.
A web form, yeah, this word I was searching. Exactly, thank you very much, Mikko. Exactly, a web form. This is, of course, at the moment in Finnish, since the operators, forest operators, prefer the language Finnish. And we want to get the information, what can we improve in our service, what is good at the service, whatever. Let's see what's coming out there. So our latest updates in the service were we have implemented and improved bias correction for the seasonal forecast data, improved the snow depth data, updated the trafficability map with better coverage. We synchronized the zooming in the time series in the web application. Also, we created a separate validation site. This is important for the for Metsäteho, for conducting the user survey, summer user survey, and also for dedicated in-depth user interviews, which is an upcoming task. Then direct weather forecast is added into the service, as well as FMI observations, and the tree density layer is added. next steps for the service is that we are investigating an implementation of our service outside of Finland. We will extend our dissemination activities. Then, as I said already, in-depth user interviews will be conducted by Metsoteho to evaluate the service and its performance. The user service will ongoing work. We have to extend the number of users. We have to check out how we are ensuring sustainability of our operational service. And maybe we are adding also the threshold selection, how the trafficability is calculated, maybe in a way that the user can define that by itself. Yeah, this is to end now my presentation, my last slide. Thank you very much.
Thank you very much, Miriam. And yeah, that was a good presentation. Let's go to the next one, Jaakko. So you want me to share?
Yes, sure.
Yes, it is. So I have so many windows open. It takes a little more time. Where was it? There. Share and presentation mode. Where was that? Slideshow. Begin. So I guess it's up there. So go ahead.
Yes, yeah, I can see it now. Yeah, so unfortunately, my slides aren't as nice as the other slides from our other panelists. I was thinking we only have a few minutes per pilot, but that's fine. So anyways, my name is Jaakko Ikonen. I work at FMI. I'm working on a hydrological model that's actually also used for the forestry app and for hydrological forecasts for a hydropower company in northern Finland. It's called Kemijoki Oy. So the aim of this pilot is to provide sort of improved hydrological forecasts for 16 hydropower plants in northern Finland, and also to assess on how we could provide better seasonal forecasts for the same hydropower plants. The primary concern is with snow melt, actually. We will be providing forecasts throughout the year, but definitely in northern Finland, the biggest issue is snow melt timing and snow melt volume into these into the dams, basically. So we're a little bit delayed in this project due to kind of lack of human resources and then having to work on the forestry project. But nevertheless, we've gotten a lot of things done, and we've put a lot of emphasis on model validation activities. So this has been, during this year, one of the main tasks is to sort of run the model in hindcast mode and to see how well the model itself performs, because the accuracy of the model is extremely important in this case, because Kemijoki Oy are also getting forecasts from another place, and they say they're not particularly happy with that, so we're trying to improve on those. So it's a quite difficult task. The seasonal ensemble forecast, what we're going to do is provide them with 90-day forecasts, and it's, to be honest, at the moment it's not 100% clear what is the best way to approach this issue. So we're still kind of working on this, but hopefully we should have something in place in the next few months, so that for the next spring we could actually provide them with meaningful forecasts that are sort of understandable. So what happened this year as well was there happened to be a record amount of snow in northern Finland, and Kemijoki Oy contacted us and asked if we could also provide some forecasts and nowcasts on the situation on top of what they already are getting. And that's, of course, diverted a lot of our time. And one of the problems was that we didn't have a data dissemination service ready yet. So everything would, although the model itself is operational and working automatically, but still there was no sort of post-processing available. So that had to be done manually, and then every forecast checked manually and so forth. It was interesting actually that with regard to the seasonal forecast for last spring is we made the first seasonal forecast in April, mid-April, and that happened to be quite accurate. So if we looked at the ensemble mean, what it predicted was that there would be a single peak, a very high runoff volume, sort of at the end of May and beginning of June, which is basically hasn't happened for the last 25 years. So it was actually, because I had to do the forecast manually, so I wasn't sure, should we trust the ensemble mean or what is sort of climatologically more sort of, what's the word? Probable, actually. So anyways, then we did another forecast in May, which is interesting that then the May forecast gave us a completely different answer. So there's a lot of work to do in the sort of science behind all of this. But otherwise, the model itself, we've tested various meteorological forcing data sets, and it seems to be working quite good or quite well. Had I known that we have more time, I would have actually liked to show you some results. But unfortunately, I don't have anything prepared for this meeting. With regard to building the data dissemination platform, we had some issues with our FMI SmartMet server, which we were planning to use, and that as well has caused delays. But nonetheless, we enacted a contingency plan because we need to have something in place for this winter so that we can provide Kemijoki Oy with a dissemination platform rather than having meetings and discussing things on email. That's unworkable. So yeah, Mikko, I guess the next slide.
Okay, next.
Okay, so basically on the left, unfortunately, there's a very small picture. So that's sort of that's a screenshot from the contingency plan sort of data dissemination service that we've built so far. There isn't any real data there yet, but we should have that in just the next coming days. So this is just a mock-up. This is actually 2018. Right now there's data from spring 2018. We're just testing different colors and discussing with Kemijoki Oy on how to, or what colors are appropriate and so forth. Hold on, I can't kind of see those slides now. So anyways, okay, so as a status report, basically we could say that the front end is nevertheless now, I'd say 95% done, as well as the back end. So right now I'm actually rerunning the hydrological model again to get some results there. Right now you can already get sort of two-dimensional maps that can be zoomed in and panned in. Right now, you are not, if you click on the map, you still cannot get the value of that point, but we're working on it. It's coming soon, hopefully even by the end of this month. And then also there will be sort of static stream flow and actually hydropower plant inflow forecasting points that can be clicked, and then you get hydrographs of inflow and stream flow. So the second phase of this is to add, or sort of also actually to test this, because right now the model is running with ECMWF high-res forecast data. So what we want to try to do is sort of also run the model sort of hindcast and nowcast with in-situ observations from FMI. Probably, or they should yield better results. I'm actually running those results at the moment to check if that would improve or further improve the model results. And also the 90-day ensemble forecast needs to be discussed within the next month on exactly how to do this. And this will be done internally first and then with Kemijoki. Okay, and then phase 3 during December is we want to add Earth observation-based snow data onto the service so that we would have snow water equivalent maps and fractional snow cover data as well. And also soil freeze thaw maps. This was requested by Kemijoki Oy. So one of the problems they're also having at Kemijoki Oy is that there's a lot of data, but it's kind of scattered around over various web portals. So what we're trying to do here is sort of also not only just provide a forecast, but also gather data from other sources and then provide it in one platform. And that's why you have the two maps, for example. So you can compare our model with, let's say, satellite data, or perhaps even another model. And let's say that the satellite data, our model, and another model all agree on something, then you can be pretty certain that the forecast is correct. And so there's less uncertainty. Then the sort of final phase for this sort of larger project phase is what will happen this spring. So we need to have the service up and running, and then we will have Kemijoki Oy try and look at the data, and most importantly, we will interact with them and discuss ways or what to change and sort of how to move forward if there are any issues. That's pretty much it. Thank you.
So yeah, thank you very much, Jaakko.
All right.
That was good. And let's have the last one. So I stop sharing and Andrea start sharing. And go ahead when you're ready.
Yeah, thank you, Mikko. I share my screen. And just a second. For some reason, I don't see my presentation on my screen. What happened? Although we have tested this.
Yes, the list has also this more windows. Maybe it's there. I also
I see all my windows except the presentation. I don't understand what's going on.
Start it again.
But I start again. Now it appeared. Good. I hope you can see my screen.
We do. Put it in
okay.
Mode and it's
Good.
perfect. Excellent.
Excellent. So the pilot 5 is the seasonal preparedness, and I'm going together with my colleague from the Academy of Athens, Stavros Solomos. We are going to tell you about the service we developed within this pilot. Actually, we are focusing on two sectors, the transportation and tourist sectors, because both are impacted not only by the climate change, but also by the interannual climate variability. So what we do in this pilot, we aim to increase preparedness and resilience of these sectors to interannual climate variability through user-oriented climate services that provide tailored sub-seasonal and seasonal forecasts. Finnish Meteorological Institute is focusing on transportation sector in Finland, and the Academy of Athens on the tourist sector in Greece. And our users are the Vianor company, which is the biggest chain of tire stores in the Nordic countries, and we develop for them the sub-seasonal and seasonal climate outlooks for winter tire season and retail activities. And the Greek partner user is the Institute of the Greek Tourist Confederation in Sete. And my colleagues from the Academy of Athens developed the new high spatial resolution seasonal tourist indicators for them and for the tourist companies. So I'm going to present the FMI activity, which is related to the winter transportation safety and the climate outlooks for this. What has motivated our work? Well, in Finland, being in a Nordic countries, the use of winter tires is required between November and the end of March if the winter or if the weather and road surface conditions require so. But of course, winter might start in different time of the year, maybe in October, late September in Lapland, mainly only in December in southern Finland. So actually the time of winter tire installation varies from year to year. And so far the winter tire companies do not have information on long term, but could be used in their activities. So our goal is to develop tailored sub-seasonal and seasonal forecast products with focus on winter tire season and winter driving conditions, which serve the tire companies to plan the distribution of tires and also to provide information for their customers about the proper installation time of the tires. And as I already said in the pilot too, we have a very close strong collaboration with the user. We work together with Vianor from the very beginning of the pilot. We planned the indicators, the products, both the sub-seasonal and seasonal forecast products. It seems that they are also much more interested in the sub-seasonal scale, so in the coming 6 weeks, than the seasonal scale. We co-designed together these products for them. In some cases, it was really easy to define the thresholds or the criteria which should be applied to the weather for the certain products. But in some cases, it was pretty unknown. It hasn't been used before. So it was a lot of work to define those criteria for the products. We harmonized the request on the visualization and also delivery form. The user again wanted a pretty simple visualization form, maps basically, and they do not require time series of forecasts. And they will pilot the service during the coming 2 winters. So they already started to use our service actually, provide feedback on the service, on the usability of the service, and we can improve it. So basically we iterate the service together with them. And then I listed those climate outlooks, what we develop. On sub-seasonal scale, we have 4 products, the winter tire season, which includes the onset of winter tire season in autumn and the offset during spring, the probability of freezing temperature, probability of snow cover and snow depth. And as you can see, we provide a probability forecast for these outlooks, except the snow depth, where we basically give an absolute value for the snow, for the accumulated snow. And then the seasonal climate outlooks, the probability of snow cover and probability of freezing temperature. These are outlooks for the coming 3 months, basically monthly maps. So we describe the average conditions for the coming 3 months separately. And I will show you also some examples. First, about the sub-seasonal climate outlooks, they will run on the FMI server. We already set up an operational service for it. And we use as input data the ensemble prediction system from the European Center. Of course, as I already mentioned before, the skill of this forecast, the quality of forecast differs. So we first had to make a skill assessment of the forecast data. We already know, or we found out that, for example, for temperature, the forecast seems to show warmer conditions for autumn. So we have to reduce this error from the raw data through bias correction methods. And we apply this bias correction before computing the products. And then we compute all the sub-seasonal forecast products, and we visualize those through maps. of ensemble mean forecast and of probabilistic forecast. I already listed here one map. This is the winter tire season, for the winter tire season. But actually what we have is a 6 static map describing the weekly conditions, so the weather condition averaged over a week. We also have an animated version of the 6 map, and we provide a description of the climate outlooks, which tells what is that product, how was that defined, and how to interpret it. Of course, we provide a demo for the users, but it's good to have their detailed description. And these forecasts are updated 2 times a week, on Tuesday and Friday. So basically we talk about a fully automated operational service. And the first version of the service is already running. It has the winter tire season outlook, and we provide to add the rest of the outlooks during November this year, so they can test it. And the user can access the forecast on the Ilmanet platform using the credentials. It's not open to the public, only to the user at this stage. And I plan to show you the service. So I stopped sharing, and I will share now the service, and I hope you can see it. Yeah, so this is the Ilmanet platform where we have now the winter tire season. Sorry, this is partly well, mainly in Finnish, as we are dealing with a Finnish user. So as the user enters the platform, he gets a description of the product, winter tire season outlook. What is it? What are the criteria which are taken into account when computing this product? For example, for the autumn, we say that the winter tire season starts when the minimum temperature is below 0 degrees for 2 consecutive nights. So, and then it can visualize the product, which is now the animation of the product. And you can see how the condition changes during the coming weeks. So this is the forecast starts now with the next week. Right now the service has a strange feature, because when we do the updates on Tuesday, it shows only starting with the next week, so it shows 5 weeks, but when we update it on Friday, it shows 6 weeks. So this is something we are working on. But anyway, we have here the start of the season, given the improbability. So what's the probability of having conditions needed for winter tires? And then in the spring, it shows the probability of ending the season. So if you have a look to the map, you can see that, for example, next week, the probability is pretty high, over 60% in Lapland, but it's pretty low in southern Finland. And of course, we explain to the user how this probability should be interpreted, that basically when the map shows a probability of 20%, that means that only a smaller amount of the ensemble members show the probability of having, or show or meet the conditions for that for that product. So now I will come back to say a few words about the seasonal products. Just a second. I hope you can see again my slides. So why So this was for the sub-seasonal outlooks. And as I mentioned, we also provide seasonal climate outlooks, two of them, the probability of snow cover and the probability of freezing temperature. And this we run on the Wikio platform, but will be published on the FMI web portal. And we use again the data from the European Center, the forecast system. The forecast system, we already did a skill assessment of variables of snow depth and temperature. We selected the bias adjustment, those bias adjustment methods which improve the best the quality of the forecast, and we apply those bias correction methods and compute the outlooks and do the visualization of those. The service is not finalized yet, but I can show you one example I just made manually. It's the probability of snow cover outlook, which was initialized in October. And it shows, well, as you can see, it shows a pretty low probability for snow, for example, for October in southern Finland, which is quite realistic. Actually, the snow forecast was surprisingly good quality. But these maps will be updated every month after the 15th of each month. And again, we will provide information about the outlooks, how should those be interpreted, and we will also have a demonstration for the user. And we plan to have the first version running during this winter so that we can improve by the next winter using the feedback after received after the end of this season. So this is from my part, and I will ask then Stavros to present the activity from the Academy of Athens.
Okay.
Hello from my part. Thank you very much, Andrea. So yes, the idea here is to design and implement a service that will be relevant to climate, a climate service that will be relevant to the touristic sector in Greece. The idea comes because most of the times tourist destinations are more attractive due to their microclimate conditions and most of the times different than average climatic conditions climate there. And as you know, especially in Greece, due to the complex terrain and the coastlines and the mountains, there is a significant variability between areas otherwise neighboring. And this is why we have started discussing about ways to downscale this information so that it is more relevant for touristic applications. And we collaborate with the Greek Tourism Federation that is in Sete in Greece. We co-design this service together. Coming to give from real life needs and to discuss simple questions like a tourist that visit Greece or that they want to plan a visit in Greece, and they have several options on which places to visit and to make their plans accordingly. Climate information could be one of the factors that could assist people to make their travel plans. And the request also from INSETE, the Greek Federation, is to come up with a very simplistic output so that it could be potentially used, even in hotels and for the public to be easy to understand and to be a tool that can help people to take decisions on the vacation planning. And of course, when we come to this COVID-19 era that we are now facing, tourism is one of the sectors that is facing a lot of problems. And the long-term planning is somehow questionable in these days. This is from one part, but also due to the increase that we see that is related to climate change in extreme weather events and weather types that were not that much, were not used in Greece to such type of weather, like, for example, Mediterranean cyclones that we're having for the past 2 or 3 years. And so there is an additional need to provide a high resolution short terms that will be weather relevant for short-term planning. So please, Andrea, next slide. Thank you. So the whole service is designed having in mind the different scales that may be related to this to climate and touristic applications, and we call this service criterion, which comes from Cultural Heritage Touristic Bioclimatic Index. And why cultural heritage? Because as we discussed with INSETE, with the end user of this application, it was suggested that we focus on the 18 UNESCO World Heritage locations in Greece and prepare the service and the pilot for these specific locations, which will be, of course, afterwards possible to be extended and include more information. So basically, we are trying to implement a seasonal, let's say 3-4 months forecasting of bioclimatic indices based on the ensemble, on the C3S ensemble members for these specific sites, and also downscale with a dynamic downscaling with the WRF model for fewer ensemble members. So we have the entire risk covered, but also focusing on these monuments of cultural heritage. Because, for example, if someone sees the seasonal forecast in Greece, most of the times it is like a difference of 1-2 degrees between the entire country, which is not realistic. And it only becomes relevant when you go down at high resolution modeling downscaling, where at least you have the impact of mountains and coastlines implemented in your service. And also an actual short-term weather forecast that will assist people to take decisions, that is the criterion application. So the individual components have been mostly developed and tested, and we're now working on how to link between them and the automatization processes and things like that. But of course, the front-end design, which will be again discussed and co-designed with INSETE, is what will, let's say, decide the success of this pilot, and if it will be actually used for real life decision making. Andrea, next slide, please. So a broad idea of what this service could look like is to include, as I mentioned earlier, all these UNESCO cultural heritage monuments in Greece. And of course, there could be some additional information or some a simple interface to browse through this service. And let's say that someone visiting Athens, for example, and having a couple of days to spend in Greece before going to a final destination for vacations or for whatever, you may have an additional tool to select which direction to go. For example, you could go and visit Delphi and avoid, I don't know, another area, let's say the Olympia, due to extreme heat wave or something like that. So this is the broad idea of the end of the front end interface that needs to be, although the back end is quite complicated and sophisticated and with a lot of scientific and technical questions, the front end, we want to keep it as simple as possible. And with this, Andrea, I don't remember if we have more slides. I think that's it. Yes.
Okay.
So, yes.
I guess that's it. Thank you very much, Stavros and Andrea. I do see that we actually have Ville now online, and he put to me a slide. So this is a question to Ville, if he wants to share his screen, or should I just put up the slide that he sent me?
Hello, yes, sorry that I'm late, and but now I'm here, Mikko, in order to avoid more technical difficulties. So if you can share the slide.
Here's the one slide that you sent me, so
yes,
go through it and then we can continue. I just say one thing. There was the idea that people would write into this question area something about themselves and what they are interested in this session. Please do so now, and then let's see what we can discuss afterwards.
Great. Yes, short update from Climate Pilot 1, Global Carbon and GHG Emissions. At the moment, Max Planck Institute is preparing first fully Python-based flux conversion towards the more operational direction of the tool. And CMCC is currently developing a global data collection procedure that would allow us to collect new eddy covariance data sets faster than it's at the moment possible. And in ocean domain, the most promising candidate to calculate the ocean and atmosphere CO2 fluxes based on SOCAT and Icos data will be at some point implemented, but the ocean partners have such a situation that they have some kind of technical limitations before they can start the implementation. But we are expecting some preliminary results in years 2021 and 2022. And then FMI is also developing an independent product that could be used to validate FluxCom and flux engine derived carbon sinks and sources above terrestrial and ocean area. And this is probably the version of the service, or the part of the service that will be implemented first. At least this is at the moment the impression that I have. Yeah, that's all in short. Thank you.
Thank you very much, Ville. That was good. we got you also on board. Wow. So now we do have this last part, which was to discuss around a few questions. Now it depends on who is online for this event, and I mostly have seen names that are all involved in the showcases, but there are a few persons that I don't know, and who might want to know about what we do or have interests in climate services. So maybe one of you might want to just kind of speak up and talk, present yourselves, tell us what you do, and then we would, get our experts from the different pilots, see what we can do for you. So is there anyone like that here? There's also a very interesting null staff 1 person that, for example, would be interesting to know who he is, or she. But I guess this is really not interesting for anyone to use our kind of expertise now. But I think, well, then let's just use it more from the showcase point of view. I'm really happy that we have already so many still things that are also on some web pages and can be kind of like tested and seen. And I urge all the other, let's say, services to get us to that stage, because I think by the end of this year, so the sprint 1 end is really the one where, well, the commission and all the kind of like who gave us the money, let's say, interests are looking at what did you produce. And it really was a lot about us having services and not just being there to do research actions or development. So I do see that we are not far away, and we will have, for most of our actions, something to show. I do understand that the pilot 1 having these issues of losing their co-designer can't maybe do that. But in that sense, for the rest, we are on a good way, but let's just finish it up. And I do see that when it comes to the VKO platform and what we have there as on the server, that is something that can be used by others as well. So in this case, it's really a point that if you have a interest, so it can be directly just map service layers from these seasonal forecasts. So we have now for this bigger European window, which covers all of Europe and even Northern Africa and a lot of the Atlantic, that for this big European window, we do have always every month on the 13th when it can be downloaded. So let's say on the 14th of each month, we have that data in. And then I'm doing this kind of bias and variance correction method, both with ERA5 and ERA5 land. So the ERA5 land is of course just on land pixels, but in that case it's done in a way that the ERA5 is then used for the rest of the area. So this is blended in so that it's still everywhere, every grid point has data, kind of data set. And with these 3 different data sets, just to make single point time series, which our SmartNet server is good at. So there's a time series plugin that you can get, for example, a CSV file directly from a web address on demand to any point in this data, any lat long on this area. And even if someone would rather want to put in city names, we can also arrange that one to work. At the moment, we don't need it because we click on the map, then it's anywhere latitudes and longitudes easier. But all these features are there. And if others are interested to use it, we would want to share. So it's mostly used in the harvester seasons, and probably it will be used for the hydrological system as well. But it's kind of like open for anyone to use because it's meant for this showcase. So please contact me and we can organize things in this respect as well. Anyone else want to share something, ask something? Any questions to those pilots that presented? Now is the time. And we still have 15 minutes, so good time to discuss. You are a tough audience. Aye. But
Mikko, from our side, I just would add some information. What we are producing or what we are doing now, it's more in a kind of testing phase, not really in an operational sense. So, but our way is to provide really the data and results, and probably we want to use the Wikio infrastructure too, really to set up these processes or transfer our algorithm and calculation processes into this Wikio platform. And it will be necessary if we scaling up these products to other cities and to other areas in Europe, I guess. In Europe, I guess. So, but for now and yeah, after 1 year, so running this eShape project, so we are not really ready for this.
Okay, well, that's not the case that we all have to have something successful. I think we are still, as a showcase, quite well, kind of like on the verge of having actual services compared to some of the others. But I think that's the aim of this whole game, and sprint 2 is then the one where to try to get out and get something shown. I guess for the Austrian case, it was anyway that I don't know if you want this co-designer company that you had involved, that even if they make some kind of a web service, that could be something that we then can just promote and show, because I think this is, well, the idea is that these kind of services would get also the help from the rest of the project, which is very much trying to see how can we market things better, how can we help them to find financing, for example, if they need kind of new, fresh money, which is not so much, as we mostly are kind of research organizations and public institutions, that we are not looking for that. But if there are companies involved, that they are very welcome to kind of like use the services within this project. That's one way of doing things as well.
No, you're right, and it's also this company you mentioned, Weather Park, has more focus on her business model on microclimate situation and calculation, and of course they use also as basement or database, yeah, long years or long-term scenarios what we are producing. But of course, also when I go to this pilot regarding cultural heritage, it will be also interesting also to have a look on this, and probably we can have also an intersection and a common discussion about this.
Yeah, definitely. I think that's actually a really good point, that when we find a kind of simple index or a simple way of putting some touristically important things together, then the point is really not just to have it necessary in Greece, but the whole point is that when we have something in Greece, how can we make that appear in other places as well? And then it would be our other partners to do something about that, to kind of like find what are the points that we want to produce it for, and if we can move that away. And I wanted actually to say that when we had this, so for this, I guess this was the first time that now 5 new pilots were added to the eShape project. We did not get any climate pilots, even if there were actually, I guess most applications had actually climate clicked, but I and Andrea, thank you very much for your hard work as well. We had to go through all these proposals, and in many cases, we have to be a little kind of boring in the sense that when they were actually more talking about something called maybe some weather kind of phenomena, or they were just talking about, let's say, that somehow it is related to climate, but they did not use any reanalysis data, so they didn't look backwards or forwards in time specifically. They were looking at the now moment only, for example, for some things, and that seemed for me to be something that, hey, let's keep them then in the other areas where they also were applying to. So they were in disasters or in health or other topics. So now we don't get a new partner into our showcase, but this game will go on to have another round next year. So next summer, again, there will be applications possible for new pilots to be added into eShape. And obviously, I think it would be good for our showcase that we also find someone. And some proposals were not that bad, but okay, it was 31 or at least over 30 applications, and only 5 were awarded. So the one that was good in climate wasn't then overall good enough to go into the 5. But then in that sense, I think we should also encourage and for example, Weather Park, if they would want directly to get also money and not just the data that you provide, that they would be one possible applier next time. So we could well see this also as something that we should promote ourselves. And of course, we are even eligible to ourselves to propose a new pilot. But yeah, it is then I have to at least let's say evaluate them. So I will not myself do any proposals, but you are free to do and try more. And then I would encourage that, because yeah, it wasn't so much fun to go through those 12, or it was at least 12 proposals that were then not very, let's say directly related to us, and read that through and try to think about how many points you give for this and that and there. But that's why I would actually want to see much better proposals next time who are climate relevant, and then I have fun doing the same thing again. But hey, any other comments? Or we can of course also close the sessions. We have time to then grab something to eat before the next round, where I do actually have to somehow bring this session together and present it to the whole consortia. But hey, thanks otherwise for good presentations. Left to hear these and see them, we are on a good way. So anyone want to say anything? I guess not. Thank you very much. And yeah, or Stavros, you want to say something?
No. I just wanted to thank you.
Well, then everybody put their video on now, and then we just wave each other together. So just don't be shy and click on the videos, and we are all on screen for a while. This goes on the recording as well, which is also always great. And then thank you.
Let's hope that our next meeting will be, with physical presence. Somewhere.
Yes, sure.
Yeah.
Sure. I really like to see
definitely.
that. I'm getting a little bored by my background, so my home. But it's really not good for always being here. So.
Okay. Thank you.
Yeah.
No.
Thank you, Mikko. Well done.
Bye.
Bye-bye.
Bye.